that. Okay, perfect. All right, everyone, welcome to day number 2. Thank you very much for all of yesterday's reading. It was very interesting, seeing where you were from, learning a little bit about your place. Looking forward to more of that during the term, right? Okay. Today, though, what we're going to do is we're going to head into a little bit of math today. Not too much, just enough to start getting warmed up. You saw how yesterday was, right? Instead of ending at 3:55, we were ending at 4:55 for about 5 minutes until we got it worked out. All right, so I have to warm up as well, just like you. This is what we're gonna do today. Basically, 3 topics that we're looking at. One is called factoring. And as a quick reminder, that's making something like this look like something like that. Okay. I did say that you're allowed to use calculators and all that, but I think for this part, you're going to have to put it at the side of the desk. You can have it nearby, but really the point of this is to get your brain going and be able to do some mental math. Okay. So this is part of that first section. The second section has to do with exponents. And these are the little letters that you see up there sometimes. If you have something like this, just as a reminder for those of you who might have seen this before, x times x times x is x cubed. Yeah. And then all the rules and such that go along with that. That's going to come over the next couple of days. Okay. The last section, yeah, it's basically some arithmetic. That means some multiplying, like we tried yesterday. 6 times 8 is perfect, 26. Yeah, so that's kind of why that might be why yeah, of course, why we're gonna spend a bit of time on it today. We got some of that stuff. We got something called prime numbers to look at, square numbers, cubic numbers. All right, all these things. And that'll be the class. Oh, and a little game at the end. That'll get us ready for some other stuff. It's yeah, I'm not going to tell you. It's a secret surprise. It's coming up. Okay, that's from me. From you, any questions? Anything we got to think about? No. Lives are all good. Of course.
The faster we start, the earlier we start, the earlier we finish, or we'll finish at the same time.
Early. Oh, like for class, the earlier we start, the earlier we end.
I mean, if we start like right now.
Like now.
Are we going to finish? Like, can we go earlier than the time?
Oh, can we leave early? Did we start early?
No. If we start early, can we?
Oh, did you want it? Do you want to start at 2:00 instead?
No. I mean, early. I mean, just right now without questions and stuff. All the pain. Just like start.
Just get at it, you mean? Yeah, I don't know. We got stuff to do. When it's finished, then it's finished, I guess. Hey, yeah. So then no questions. No, it's more for like life stuff, homework and that sort of thing. But yes, none for that. Okay, so let's get on to the first topic. See what's going on there. What's that? Oh, it's your homework. Perfect. This is the last slide. Jump to the end. Okay, little memorizing there, couple of worksheets. That's about it. Nothing horrible for the first day. Now, this is kind of cute. All right, what's going on in the first 2 pictures there? Zoom can shout in too if you want. If you can see the camera, the pictures there, what's going on in the first two, the top two pictures?
It's cashier. Maybe I'm not sure.
Okay. From class, we got someone buying something. Yeah. The, yeah, exactly. Cashier is saying how much it is, person's buying it. Zoom, what did you say? Hadil, was that you?
Cashier. Yeah, I say cashier.
Yeah, cashier as well.
She's giving her credit card.
Giving credit card? Oh, could be. That's boy, you have good eyes. In class, that'd be right. That I guess. Is that a credit card or is that cash? Credit card? Okay, I trust you. All right. So situation is transactions going on. It's got to be correct, right? How many times do you go and buy something and then don't know how much change you're going to get? Right? That doesn't happen actually. If you use a credit card, you just go beep, then it's gone, right? But you should be able to check your work, check the results, check the transaction, right? So that's why we're just taking a look at number 3 today. You know, be able to have some fun with getting good with some numbers. All right. The bottom part. Can you guys tell what's going on there? Is it easy enough to see or? Huh? Stops. Stock. Oh, no. Okay, I'll have to work on. I'll show this picture tomorrow. Maybe it's pretty bad for class here. Zoom, can you help out? You got a better view.
She looks like she's on the phone.
Like this thing, she's think about this thing. I don't know.
Nice. If you can see the camera, then yeah, that's a better description of what's going on. That's a person there with a phone. The stocks that you see are in fact the radio signal. Okay, and and it's coming out of the tower, that not the sun, but coming out of the tower that you see at the top of the on the right hand side there. Okay, now as I mentioned yesterday, when you make a phone call, you don't want to be phoning a bunch of other people, right? You want to be talking to the one person only. And so on it, like this stuff that we're doing, this factorization is like the bare bones beginning of how this all happens. It develops instead of using the numbers all the way to 10, you throw in the alphabet. So you get weird letters and weird combinations that look like this. Like that could be someone's phone address, right? Because instead of having only 10 things now from 1 to 10, instead of having only 26 things from A to Z, we can mix them all up now, right? You know, and so we can end up getting some pretty big numbers, which are needed for the big number of computers, cell phones, all those other things out there. Okay, so pretty fancy. Now, what we're doing though, really not so fancy to begin with. What do we got here? We got, first of all, with factoring here, what it is. Okay, if you're asked to factor something, it's like I just showed you here. All right, what you're asked to do is write down the numbers. Now, when multiplied together, give you the original one. Okay, so this is where our practice begins now, right? So if the factors of 21, factors are 1, 3, 7, and 21, right? Because you can see how they're paired up. 1 and 21, 3 and 7, right? So that's all of them. Okay, so that's what we're doing today for the first section. So there might be only 2 numbers multiplied together, or there might be more than that. Okay, but you can see how this looks. 6, for example, 3 times 2. It's not so tough. This one here starts to be a bit of a list now, though, right? 3, 4, 6, 12. What's missing? 1 and 12. Yeah, nice. Good. Nice and fast, I might add. That's good stuff. Okay. Yeah, 1 and 12 missing for that one, but for today, for the start, that's all right. The next one. Oh, yeah. Importantly, another way of writing 12. And what that is, yeah, in class we have someone commenting, you got a 3 there, looking at the 3, 4, right? Peter, you can see that? No? You can join Zoom if you want then and look at your phone. But we got 3, 4 here. So 3 times 4, the 4 can be broken up so that it's now 2 times 2, right? Okay. And so at the bottom line there is 12 is equal to 3 times 2 times 2. Okay. So these are all like examples of factoring. Now, the one on the top, I'm looking at the 12 here, the 3 and the 4, the 6 and the 2, that's like regular factoring. The one on the bottom is getting down to prime numbers, which is special for the phones and that sort of thing. Okay. Yeah, there you go, 91 there. Who knew 7 times 13, right? Now you do. Okay. Now, this is what we were just looking at with the 12 there. I'll put it on the screen so it'll be maybe a little bit bigger. Prime factoring is when you get a list of prime numbers. So we had the 12. And I think you'd agree that you can go 2 times 2 times 3, right? And that'll get you up to 12. Okay, and the point of this slide is that all of these now are called prime numbers. Okay. In class, everyone is clear what prime numbers are? Are they new? Yeah. All right, perfect. So there's the explanation, or there's the list actually. The explanation is this part only. All of these numbers, they have only 2 factors, not like 12, right? All these factors have only the number 1 and then itself. The number 3 has a factor of 1 and itself. That's the same for all of these. Okay, this is like a property of numbers, which is a whole thing, right? Whole subject in itself. Okay, and so here they all are, all the way up to 100. Not gonna lie, because I wouldn't do that to you guys. I searched them. I found a nice list. I cut and paste, and boom, they were there. Okay, automatically. But I'm telling you, even myself, I got to check over to make sure. Go, is 57 prime or is it not? No. What are the numbers? 3 times what? 19? Yeah. Do we need to check that on the board, or is that everyone okay? Yeah. I think everyone's okay. Yeah, 3 times 19 it is. Okay. So a couple of things to notice there. First of all, I'd like you to have these memorized, and I'm going to do it too. As I told you, cut and paste, right? But I'm going to do it too. And then we'll make sure that we keep one another honest over the next couple of days, 2 days or so. That'll be good enough, and probably in there for forever, and then our lives will be better for it. The second thing I want you to notice, right? The number 57, not that big. Okay. But did you know the answer right away? Little struggle? Little struggle, right? See, that's how the security can come in for computers and such, right? We might have a number in front of us, or the computers might see a certain number, and these numbers can be factored, right? But to try and figure out what those factors actually are takes a little bit of time, unless the computer knows it, unless you know it, right? And so that provides that time needed to find the factors is the bit of security that can be created. And again, if we use the trick of having the numbers of 1 to 0, throw in the letters, right? We got something pretty weird then to try and factor, right? So helps with the security a little bit, right? Then I could be talking on my phone on 57, and I know it would take you guys quite a little bit of time to get the, what was it? 3 and 9, 9 and 3, 3 and 13. I forget. What is it? 3 and? Perfect. 3 and 19. See? You figure it out. Oh, boom. Now you're in my phone call. Okay. So, yeah. So for today, for this slide, let's get them memorized. I'll put this up later on. You can, unless you're copying them down now, put them up later. Also put this on Teams for you to see. Okay, and that'll be useful for the next couple of days for sure. Now, without a word of a lie, people are trying to find patterns inside of these numbers, and importantly, try and find the equation for these numbers. Right? Imagine having the equation for prime numbers. I want to know what the 10th prime number is, so I put a 10 in there. Boom, comes up. Okay, doesn't exist. People don't know it. If you find it, then you are a very special human being. Your name will go down in history. Okay. People have been sneaking up on it. They're finding out different things about these prime numbers. They have some formulas that are close, but yeah, they don't have the real one yet. And so it's a math, there's a few of these things out there, a math prize that's waiting to be won. So I'm telling you guys in grade 10 so that you have a long time to think about it. That's why. Then your chances of increase, chances for getting this private prize increases, eh? Okay. Zoom, are you okay with that? You're going to be winning some math prizes out there?
Yeah.
Yeah.
One person, oh, they both are. Good. Okay,
Yeah.
so this is one way to do it. All right, figure out the equation. Oh, not just for these primes, all of them. Yeah, all of them. Okay, that's there. Back to class now. What do we got here? Those are all prime, 18 all prime. I should let you guys do this. What are the numbers for 18? Okay, so we want the prime numbers, the prime factorization. Actually, maybe I'll just show you for now, and then I got a couple of tricks to actually find the prime numbers. Anyone happen? Sorry, Mark, go ahead. From 2 times 3 times 3? 2 times 3 is what? 2 times 3 is? 2 is prime, actually. Yeah, 2 counts as, good to mention this, by the way. It's the first one. 2 is prime for sure. What are the factors of 2? 1 and 2. So that makes it. I was just gonna say, that's why I went back to the screen. So so look at this. 1. Is it a prime number? No. Okay. Do we vote, or is this a real answer, or is there a real reason? Okay, so no, why not? Because, so 1 has that special property, yep. 1 times 5 is 5. Yeah? Got a guy in class saying not prime. Okay, so what's your reason?
Because one have one time one is one, and this is the reason.
Yeah, that's kind of what Danielle was saying there. The number 1 is special. You keep on getting the same number, right? Yeah, like that's so there's a couple of things. First of all, the math folks, I think they said no, that's not, or at least most of them. And I think the reason is, yes, as you said here in class, if you look at the first few prime numbers that are given there, how many factors do you see here? 2, and they're different, right? Different from one another, and see. But what about the number 1? Yeah, they're the same. If you want to even write it twice, then it's the same, right? So that means the number 1, yeah, it kind of has 2 factors, or 1 factor with a multiplicity of 2. But yeah, the point is these are the same and all these are different. So that means yeah, they're not exactly the same type of number then, right? So these are primes. So they say this one, no. Okay. At least up until, what is this, May 11th, 2021. News might come out tomorrow otherwise, but yeah, good for us here in class, it isn't until we get an official update from someone. Okay, so what do we got so far? List of primes to know, big prize waiting out there. That's what it. Got some examples. Yeah, 3 times 3, 9 times 2, 18. Or we can flip the order around, of course. And usually it is a smaller number first. I'm not sure why it's like this, but that's how it is. 100, you can break it all the way. Like 100 takes a few steps, but you can break it all the way down, right? And there they go. Okay, so what we're going to do, 2 different methods for finding the bunch of prime numbers. It's a factor tree. Anyone know what this is? Yeah? Okay, I'll show you. How does it work? I'll do the 18. Let's work on the 18 first. 18. The way it works, what do you do? 2 numbers? Yeah, any 2 numbers that multiply to 18. Okay, so yeah, we'll do 2 different versions just because you said so. You said 2 and 9. Yeah, or maybe you chose 3 and 6 instead. Okay, or even 9 and 2, or 6 and 3, right? You can switch the order around. Okay. Yeah, exactly. What you do is you keep going until you see prime numbers, right? All of them. And these, it's called a factor tree. These are like the leaves of the tree. That's the language you'll see in computer science when you do this stuff. Okay, over here, same thing. 6, what happens? 2 and 3. Are they all primes? Yeah, primes. So then what can you say? How can you write it? 18 is, as I said, usually the smaller one first, but not wrong, right? 2 times 3 times 3 like that. Okay, and you get it. Yeah, get what we had on the last page there. 2 with a couple of 3s. Okay, that's the factor tree. So with 100, we saw that. Anyone remember what it was? Yeah, exactly. See, breaking into phone calls already. 100 goes there. Sure, 10 and 10. How about 2 and 50? Huh? See? You don't have to do both at the same time, by the way. I'm just doing it to show you a couple of different ways. 5 and 2. Just for fun, I'm going to do 2 and 5. just to mess with you a little bit. All right, but no need for that, right? 5, 2, 5, 2, boom, done. So we got the primes here, just for the space here. I'll leave it like that. Okay, those are the primes. 100, I'm changing my mind, is the same as 2 times 2, 5 times 5. 50, same thing. What are the numbers? That'll be the next step. What with the factor tree, what you do is just 2 numbers at a time. It kind of focuses your thinking, makes it a bit easier that way. 5 and 10, sure. Dunya, you had something to say? Zoom, you want to jump in? 25 times 2. We could have actually, yeah. Yeah. Let's finish up here. What do we got? 2 and 5. 5 and 2, yeah. Same numbers? Yeah. Okay. So there you go. So this is called now, other words on the screen? Yeah, prime factorization. That's what we've just created. Prime factorization here. Okay. And notice what happens to keep our phone calls safe, just make the numbers bigger and weirder. Okay, so what do we got now? 424? Yeah. What do we got? Okay, 2 and 212. It's true, it's nice. Next. Yeah, exactly. 106, very nice. 2 goes into there 1 time. Doesn't go into the 1, so 2 goes into 12 how many times? 6 times. 106. Yeah. 53. Oh, see, this is okay. What the heck's with 53 now? Is our phone call safe? Yeah, it's prime. It's on the list. Okay. So then what's the prime factorization? 424 is 2 times 2 times 2 times 53, like that. Okay. All right. So this here is the factor tree situation. Okay. Exactly. It's coming up. Yeah, that's what's coming up in like the next next section for a little bit. A reminder, because remember on the list at the beginning, exponents, right? The x to the x times x times x, just x to the 3. It's exactly what we can do. I'll put it here. It's a little out of order. 2 to the 3, because there's 3. How many 2s are there? 1, 2, 3. And they're all multiplied, so it's understood. Multiplied, right? 53. Short version coming up officially shortly. So that was 424. So yeah, you know what? This is repeated division, different style for the same thing. Instead of making trees explode like this, all just 1 column. Just goes nice and fast like that. Oh yeah, I need some numbers. Same ones? Same ones. So 18 looks like this. North American stylings on the left here. I see a 2, 18 divided by 2. You're always dividing. 18 dividing by the 2 gets you a 9. And we'll do it again. What goes into the 9? 3. So 3 now dividing by, same thing. What are you left with? 3. And so as soon as you have a prime number, well, first of all, try and use prime numbers along the way. Okay. And as soon as you have a prime number at the end, then you're good. You just go 2, 3, 3. 2 times 3 times 3. That's going to be the same as 18. This is our prime factorization of 18. Yeah. And if you like, as that little shortcut, 3 to the power of 2. Okay, Zoom, you okay with that?
Yes.
All right, perfect. So that can work with the other numbers you see there on the screen as well. Do you want that back too fast? Can you see that? It's kind of weird today. Do we need more lights off or what's? Zoom in class here, we're trying to make the camera work. Lighting is weird. Okay, good people, you try the 100. What do we get again? Yeah. It's true. It will be 2 squared, 5 squared, but let's just do it in slow motion. 100, repeated division. 2, okay. Yeah, prime numbers if you don't mind. Gives you a 50 there. How do we get it? Dividing, right? 100 divided by 2. 50 for sure. What divides into 50? 2 again? 25. Exactly. Boom. 5 goes into 25 now. 5 is left. And so as we saw in the earlier slide, 2255 official, or short version looking like that. That is with the exponents in place, but coming up shortly, right? Okay, and you can do the same for the last one too, just to check. As I said, just like the course outlines, we don't need to belabor a point. But yeah, check this out. Now, instead of factors and factorization at the top, we have exponents here, and this is why, right? You could write out all these y's multiplied together, or use the clever shortcut stylings, right, in order to do it. And that is in order to represent the numbers that you see there, the expression. So that's what we're going to look at in this section. Really level 1 today only. That is just to show you how it officially now, what it means, okay? So let's look at this here. Suppose we had 29 numbers, 29 separate numbers, right? All multiplied together, just like we had in the first. I think it's probably more than 29 twos there, right? But, okay. Do we write them out each time? No. We do the, use the exponents in order to make this happen, okay? And so here's how it looks. In our top example there, we got 1, 2, 3 twos multiplied together. And then that can be shortened to 2 to the exponent of 3. So I'm going to put on the camera here some words for you. The 2's are the numbers that get multiplied each time, right? Okay, so that's called the base. That's like the repeated number. And the little number on the top, that is the exponent, the name for the section. And it shows the number of 2's. Number of 2's in this case, multiplied together. So what's helpful is when you see something like this, explode it out. Oh, if you can, if you can see it. When you see something like this, in your mind, it might actually be helpful to see the 2 times 2, the long version in your head, especially when we're starting to multiply and divide things together. So remember that this is a bunch of numbers that are multiplied together. Okay, going down the list, you can see 3 in the same thing. How many 3's are there? 4 of them. It's over on the screen here. So there's 4 3's now, 4 for the exponent. For the 10, only 2. two 10s multiplied together. So the exponents are 10. Okay. With your brains, with your calculators, you could figure out what each of these numbers are. What is 2 to the exponent 3? It's 8 for sure. Break out your fingers. 2 times 2, 4, 2, 8. Next one, 3 times 3. Yeah, it's 81, right? And there's a couple of ways to do that. Okay. So multiplying these out, yeah, something you should be able to do. But for bigger numbers, bigger calculations, it's kind of a trick to leave them like this and then work it out at the end, basically. Yeah. Hey, but anything for today though, this is it, just the shortcut there. Okay. A little note, once you start getting negatives showing up, you got to be careful with brackets and stuff. Okay, that's important. Otherwise, just shows you what you guys said earlier on. Instead of the big list, there's 2 5s multiplied together in the second one. Okay, so put 5 to the 2. It's 2 2s multiplied together, so yeah, pretty regular stuff. This slide here is with the brackets. Okay, it'll come up more often in a later slide, or in a later class, but that's there for you to watch out for. Okay, and tiny writing, this is like computer writing here. N caret to the power of 2. You might see it here, but it's only because I didn't do my homework and update it. Okay, but anyway, same symbols there. So now you know what they are. What's the short way of writing the first one? I don't know what the answer is. I haven't counted them myself. I just cut paste again. So y times y. I'm hearing from 13. 1 3. Okay, I don't want to write it down if it's wrong. Let's. Oh, it's wow. Yeah, it's tough. You got your fingers going, whatever. Can I do that? Click and drag. Day 2. No. 1 2 3 4 5 6 7 8 9 10. Yeah. And we can see it's 3 for the rest, right? Yeah. Nice. Why to the 13 it is? Way nicer. Not much of a pattern there, but what's the next one? How many? 1 6? 6 0. 4. How many? Oh, there's 4. How many rows? 5. How many in each? Yeah, 12. There's 3, 3. Yeah, I see 12 there. I broke it up in 3s in my head instead of counting all the individual ones, right? So for sure, you can check it out. Those are 2s. Yeah. So for the second one, 6 0, right? You multiply that together, it'll explode your calculator, or getting there, right? Your calculator just runs out of memory. Okay. The places to put the numbers in there. It won't work. You'll need a computer then instead. The last one, kind of cute with smiley face there, right? Okay. But how do we get 6? I got 5. What did I got? Yeah, there we go. Yeah, now I got 6. Yeah, thank you, Zoom. 6 there for sure. Helping me out. Kind of as a heads up, this smiley face can be something quite complicated. It might end up being something like this in your later math lives, sneaky, hidden inside a cute little smiley face there, but that's the situation. Okay, so get ready. Enjoy it. Enjoy smiley for now. What next? Okay, a couple lists of numbers, and then that'll be. I think we're good. Square numbers and cube numbers, right? Okay. So, square numbers. What are they? They can make squares actually. So that's kind of where they get their name. Square numbers. Those sound like even numbers to me. Do we need to take a look at that? So even numbers. These are the 2, 4, 6, 8. Yeah. 12. Yeah. I'm just saying even and odd. Maybe I should say even and odd numbers to start with, in case you don't know those words. 1, 3, 5, 7, 9, 11, right? Okay. What happens is if you draw a picture of these, and it's kind of cute. Probably did it in grade 3, right? Drawing pictures of numbers and that. But it's actually kind of a neat trick to have now that we're a little bit older. You know, if you have the number 2 side by side, you got 4, right? 1, 2, 3, 4, 5, 6. Everything pairs up. With all of these, though, you get a hanger on. Paired up. Oh, one hanging on. Paired up. Oh, one hanging on. That's what makes it, a way of thinking about it as being an odd number in a picture-wise. Okay, and even sometimes adding and subtracting with pictures instead of numbers is easier. So kind of a, cute trick there. But for us though, squared numbers, they're the numbers that have even exponents when you break these all down. The number 25, of course, comes from 5 times 5. The number of 100 comes from 10 times 10. Right? What's the next one up there? 10 times 10. See? Even number for the exponent. Yeah. 400 is starting to be big, but not impossible, right? We can break it all down with a factor tree, however we like. 4, 100, 2, 2, 10, 10, 2, 5, 2, 5, right? And then we get what we see on the screen there when we put the exponents together. Should I do that to finish it up? Be a good teacher. We got 1, 2, 3. We got 4. Save it like that. We have 4 2s there. And then we have 2 5s there, right? And I think that will match what we have there from before. Okay, so that's a perfect square. These are notable, I guess. Zeros are weird. 0 squared is 0. 1 squared is 1. Okay, that'll catch you if I ask you quickly one day, right? But so watch for that. Cube numbers, multiples of 3 there instead. Okay, so or number times itself 3 times, right? Okay, so there's a big list of those as well. 8, 5, 12, 2, 16. Okay, a whole bunch of them. Okay, we can start looking at particular numbers. Okay, is the one that's both, right? Again, trying to get into the phone call. Maybe this is the secret number that's needed, right? Okay, secret connector. So here's a little list here for the square numbers up to about 13. And then I think on the next slide, there's another one for the cubes, right? Okay, so let's get those ones down. And we'll get those ones memorized as well for tomorrow, along with those prime numbers. And then we'll take a little break, come back, play a little game. Yeah, and that'll be all right. Okay, so you guys got these? Oh, actually, here's how you can write them down. Square numbers, which can all be shown with squares, by the way. if you want to use the dots. So you got 1, 2, 3, 4, 5, space 6, 7, 8, 9, and just up to 10 there. Is it up to 10 or 12? Oh, it goes a little more. 10, 11, 12, 13, you see up there. So 1 squared is 1. 2 squared. Oh, by the way, yeah. Power of 2. Power of 2. That also is square. Excuse me. So 2 squared is, yeah, 4. 3 squared. Close. 9. Other way, yeah, I got to keep track of where the 3 is. Okay. 4 squared means 4 times 4. 16. 5 squared. 25. Yeah, I think they're all on the board, right? But try from your brain. 7 squared, 49. Boom. Yeah, that fast. That's how we want it. 81. Faster than the hand for sure. 100. What's the trick here? It is. Yeah, you do that. 1, 2, 1. I'll explain that later on today. Maybe not on the second day, but 11 squared is 121. Yeah. 12 squared, 144. 13 squared, 169. Okay, so have those memorized, okay? All right, good. The other ones, got to work at the bigger cubed ones, I think, a little bit, but still worth having nearby. Oh, can I switch this page? Yeah, okay. Zoom, you okay?
Yeah.
Someone in class is writing it down. Zoom is okay. Fantastic. What's special about the number 3.14? It's like pi. It's also going to be break time. We'll try and keep that official. Is that all right there? Go back. Yeah, with the afternoon class, you can do that. 3:14, pi time. Take a break. But we'll just get this last list up. Do that. Take 10 minutes and then, as I said, little game when you come back. Okay. All right. List. Last one. Cubed numbers. Those are them. Yeah. Same similar list, up to 10 only. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So 1 cubed. That means 1 times 1 times 1. Yeah, just 1. Nothing fancy there. 2 cubed. Break out your fingers. 2 times 2 times 2. 2 times 2 times 2 is 8, right? What's next? 3 cubed. 27 on the list. Convince yourselves. Yeah. They are. They're all there. Yeah. Yeah. Just pointing out that that we're cubing all these bases, right? These bases to that exponent. This base to that exponent creates the number that that you see there. What's 4 squared? I'm starting to forget. Oh yeah, that one's easy. 5 cubed, 125. Now it might start to be a little busy. 6. It's up there. It is 216. So I think of it as 6 times 6 is 36, right? Then it's 30 times 6, 180, plus another 36. So that gets you there. Right? 7 there. 2, 4, 3. Yeah, I kind of have that one memorized, but also it's also kind of in my calculation brain a bit. This one I go back to 2s. I know as a math teacher, I know 2 to the 5 is 32. I know 2 to the 10 is 1024. Powers of 2 just come up a lot, and so I convert the 8 2 to the power of 3. Use some exponent rules that you might not know yet, and so I know it's 512. Yeah. So this one's a little Memorize it for today. Last one. Same sort of trick. 9 times 9 is 81. So you got a 9 times an 8, which is 720, plus another 9. All right, 729. Best one for last. Power 3, 3 zeros. Done like that. Okay, so listen, here's what's going on. First of all, Zoom, are you okay with everything you saw there today so far?
Yeah.
Well, okay then. I think what we'll do then with you, Zoom, is
Hmm?
you can be free to go for today. Give me about oh, actually, what we'll do is I'll show you the homework. I'll put it on Teams, and then Zoom, you can get started on that, okay? For class, yeah, why don't you guys take,
Okay.
for just a second, Zoom. For class, take about 10 minutes. You can get up, stretch, walk around, get some water, and we'll come back and finish up with a little game I got for you. Okay? All right, so from class, 10 minutes. Zoom. Yeah, Teams. What I'll do is I'll put the homeworks up there. Day 2 homework should pop up into your lives shortly. Yeah, perfect. So there goes day 2. I'm just typing in the header there, the homework. Oh. I'll attach a couple of things there. Yeah, perfect. Okay, so that's one of them, Zoom. One of the sheets. So there's 2 worksheets that I'm giving in there. So you do all the work on a piece of paper over there on your side of the world. Okay, and then you let me know when you got it finished. I'll send that out. So that's the homework from today. I'll put the notes up there as well. Close it off from here. Okay, and that'll be good. Then we can connect tomorrow, okay?
So the homework you wanna me hand out tomorrow, like finish tomorrow, or